This is video 1.10. We are going to talk about metric system conversions now. So what we started in the last video with dimensional analysis, we were learning that T-chart method, the factor label method. Now we're going to apply that same strategy to metric system conversions. All right, so this might be a little bit of a review. These are things we're going to see throughout the year. Remember, the big thing you want to be able to work toward and master is learning how to use that T-chart, okay? That dimensional analysis. It's going to be a huge tool not only for this class, guys, but it can go into so many other things as well. So in chemistry, we're using SI units. SI just stands for System International. Okay, this is the international system where no matter where you go in the world in any science lab, they're using the exact same units. So the units that you would take a look at, if you look on your reference table on table D, they list them for you. So they give you the symbol, they give you the name, they give you the quantity as to what they measure. All right, so it's a huge piece for you guys. You don't have to memorize them, you just got to know where to look. Okay. Now, also, since we in America are one of only 3 countries, I'll offer this up. First time I've done it this way. Prize question. Okay. What other 2 countries are on the English system as well? So like we use feet and inches and stuff like that. There are 2 other countries in the world. If you come and write your answer down and give it to me, I'll give you a prize. So table C, prefixes for the metric system. You probably know most of these, but these are given to you. We're going to also kind of fill in some of the gaps. I'm going to show you why the metric system is actually a superior system than what we use here in America. But for example, in the word kilometer, the root word or the base unit, okay, that's that root word, is meter. So it's saying, okay, we're judging a distance. We're trying to measure that. Then there's the prefix kilo. Kilo means that you multiply the root word by 1,000. And you're going to see me write 1,000 or 100, guys, not in terms of like standard notation. I'm going to write it in scientific notation. This number, remember, 10 raised to a power is the same as 1 times 10 to the third. Okay, that means the same thing because when you multiply by 1, it doesn't change anything. So therefore, 1 kilometer is 1,000 meters, or we could have a conversion factor where 1 kilometer is, if I wrote it my way with the exponent, it would be that. You'll see why that exponent piece, guys, is so useful and helpful here as we go through and fill this chart out. What about a millimeter? You may know that, but if I look at milli, right there, table C, okay, 1 millimeter equals 10 to the minus third meters, okay? So that's what we're going to kind of explain here with this chart. My hope is that this is somewhat of a review. And then we're going to get into some problems together. So kilo, we can fill in these symbols. Remember, this is a lowercase k. It's hard for me to kind of reiterate that. Okay. Hecto, maybe you've heard of it, maybe you haven't. That's an H. Deca is DA. Then you've got your base unit. These are like, remember, our root words. All right. Deci is a lowercase d, centi is a lowercase c, and milli is a lowercase m. Guys, what these mean is that we're going to multiply the root, whatever that root is. So if it's grams, if it's meters, if it's liters, if it's second, we're multiplying the root by, in this case for kilo, if we go up here and take a look at our selected prefixes, there's our factor. We're going to multiply it by 10 to the third, which is the same thing as 1,000. My encouragement for you guys is to get used to doing metric system with these conversion factors. You're going to see the pattern unfold as we go through this. So conversion factor examples, we could have 1 over 10 to the third, or it could be 10 to the third over 1. The problem that we do, like when we're actually applying this to an actual mathematical problem, that's going to determine what conversion factor we have, whether it's on the top or the bottom. Remember, letting our units drive our math here. So I'm going to just use these ditto symbols here because they're all going to start with that. Multiply the root by, and then we're going to see the numbers. If you want to take the time and write it all in, that's your choice. They're your notes. So this is why the metric system, guys, is so much easier to understand, and why, you know, all the world except for 3 countries actually use it. Because hecto, now we just scale down by 1 factor of 10. So hecto is 10 to the second, or 100. Deca is 10 to the first, or 10. Like decade, you've heard that before, right? That's that prefix deca. Then your base unit would just be nothing, or if you wanted to say, hey, 10 to the 0, right? 10 to the 0 equals 1, so essentially, guys, it's nothing. We don't have to worry about the base unit. The base unit just kind of stays flat, okay? Then when we start going the other way, so we can see this pattern, right? 10 to the third, 10 to the second, 10 to the 1. Like I said, this is 10 to the 0, just to kind of help with that pattern. Oh, then over here, now we're starting to get smaller than 1, so 10 to the minus 1, or 1/10. 10 to the minus 2, 10 to the minus 3. So you can see that pattern that starts to unfold. And then with these extra ones that they give you here, like micro, then we start kind of going by 3s. Can I tell you what 10 to the minus 4 is? Absolutely not. I mean, I don't know what the prefix would be, I guess, the unit, because it's not really essential at that point. Okay, then there's nano and pico, and it even goes down further from that. So conversion factor examples, guys, would be the same. It's just 1 over 10 to the second, or 10 to the second over 1. And again, the problem that you actually work out is where you would see and kind of where you put those numbers. Your units are going to drive that. So I'm just kind of drawing, or not drawing, but writing down examples just to kind of show you how these conversion factors might look in a problem. And then we're going to actually do some practice problems here in just a second together. Okay, so let's jump in. Same idea. We're going to do this the same method. Again, some of you may be able to do this in your head now. Great. But the purpose of us going through this and working this out using dimensional analysis, guys, is to learn the concept, okay? Learn that strategy that's going to be so helpful later on. So yeah, I understand that you guys may be from math, I just moved the decimal, a certain number of places. Absolutely, that's all you're doing. But take these easier problems to learn the method of how to cancel out my units, and it's going to pay huge dividends later on. If you don't believe me, go ask somebody who's already taken the course. All right, so this is my given and my wanted. So given, wanted. So 62 kilometers is going to be in the first part of my T-chart. Okay. Now the question you got to ask yourself is, just like before, when we had like when we had like days to minutes, okay, were they directly linked, or is there multiple steps? So days, we had to go to hours first, and then we went to minutes. So ask yourself, can I go right from kilometers to meters? And where you can look is if we look back here, oh look, yes we can, because, and I'm going to use a different color to show this, kilo goes back to the base unit. Okay, so that's a one-step problem that we're going to be looking at here. So kilometers will go on the bottom, meters will go on the top. Okay, kilometers are going to cancel out. Look at, my units are driving my math, because now my units have canceled out. I'm left with the unit I'm trying to get to. So now I just fill in the numbers. So if I take a look back here, right, kilo means you're multiplying the root by 10 to the third. Okay, so the root, excuse me, is going to get that conversion factor, that number, the 10 to whatever power. My prefix will always get the number 1. And that's a little side note, guys, I'm going to write down here. When dealing with the metric system, this is where people might get confused. So if you're confused, call me over, all right? Metric conversions, the prefix always is a 1, okay? Just like I did here. Kilo has the prefix, therefore the number 1 goes there. Oops. So again, kilo means that you multiply the root by 10 to the third. So that means the kilo gets the 1, the root gets the 10 to the third. When we do this, we would get 62,000 meters, because again, we multiply wherever there's a t. All right, there's one example. If you feel confident, go on and try these next ones on your own. Pause the video and do that. All right, example 2. Write down your given, 3.2 liters. I'm trying to get to decaliters. So I've got my base, my root word, and then I've got a prefix. So I know it's going to be one step, because I'm going from a base to a prefix, or a prefix to a base, either or. Write it down, set up your T-chart. where does liters have to go to cancel out? It's got to go on the bottom. That means decaliters is going to go on the top. Cross out my liters. Now again, the prefix gets the number 1. Notice the prefix is on the top here. So 1's going to be here because that prefix means, if I go back to my chart, deca, okay, means multiply the root by 10 to the first. So the one in my fraction that has the root is going to get that factor of 10. Now, this is the first time we've seen something like this, guys, where we multiply. Remember, these are fractions. So there's a couple ways you could do this. You could multiply all your tops together and multiply all your bottoms and then do the division last. Okay? In this case, since we have ones, this is essentially just 3.2 divided by 10 to the first, okay, which is 10. So it's 3.2 divided by 10. All right? And so that means our answer would be 0.32 decaliters. Okay, so that's the first time we've really done a division problem with this T-chart, the dimensional analysis, but it's the same thing. You guys have done this before, all right, in other classes maybe. If you need help, call me over. You try this one on your own. All right, so 320 centimeters is my given. Meters is my wanted. Okay, so centimeters to meters, that's 1. So that means meters are going to be on the top, centimeters on the bottom. Cross out my centimeters. So again, the prefix gets the number 1 because centi means multiply the base by 10 to the minus 2. Okay, well, if I multiply by 10 to the minus 2, remember, we could rewrite 10 to the minus 2 as 0.01, but again, you have your calculators for that, guys. If you need help plugging in your calculators because you're getting the wrong answer, call me over. Don't wait. Don't hesitate. So when we do this, we would get 3.2 meters is what we should have there. And you could, with these metric ones, guys, ask yourself, does this make sense? Kilometers are huge, so if I'm going from a big unit to a small unit, my number should be bigger. If I'm going in example number 2 from a bigger unit to a smaller unit, I should be, I'm sorry, still bigger, smaller to bigger. Example 3, the U try, that's where you're going from smaller to bigger and it should get smaller. Now, example 3, maybe you've tried this already, maybe you haven't. Okay, notice we have 2 prefixes here. Okay, so we're going to start the same way. We have 17,000 milligrams. We're trying to get to kilograms in the end. So I'm going to set up my T-chart, put my 1 down there as a placeholder. Okay, but what's going to be helpful is when we take a look here. Oh boy, my things is just moving all over the place. All right, we are here at milli. We're trying to get to kilo. Okay, they don't necessarily go right to each other easily. You may be able to recognize it, great. If not, guys, when you're trying to go from one prefix to another, go back to the base unit first, then go to your second desired unit. Make it a 2-step problem. Okay, it's going to be a lot easier to keep track of things. So what I'm going to do here is, again, set my units up. Gram is my base unit, all right, my root word. So milligram is going to go on the bottom. I'm going to make gram on the top. Okay, cross out milligram. Prefix gets the 1 because grams milli means that you multiply the base by 10 to the minus 3rd. Okay, milli's gone, but grams is not where I want to end up. I want to end up in kilograms. So now I'm going to do another step with grams on the bottom and kilograms on the top. Grams will cancel out. So now again, kilo means you multiply the root by 10 to the 3rd. Ooh, this one's a little bit more tricky. Okay, a lot more math that's involved with your calculator. But you guys can do it. Make sure you plug it in correctly. So maybe you want to do all your tops first. So if I did that, 17,000 times 10 to the minus 3rd would get me 17 divided by 10 to the 3rd, which is 1,000. When I do that math, I get 0.017 kilograms is what you should end up with. This is one where, again, if you're struggling with the calculator or understanding the math, call me over. Don't hesitate. You guys try this one on your own. So 540 millimeters. I'm trying to get to decameters. Okay, set up my T-chart. I'm going to go back to my base unit first. My root word is meters. So I want to get to meters first. So millimeters is going to go on the bottom. 1 millimeter, 10 to the minus 3rd. Because again, milli means that you multiply the root by 10 to the minus 3rd. So cross out millimeters. Okay. Meters isn't where I want to end up, but I'm getting closer. Meters on the bottom, decameters on the top. Meters will be gone. Oh, good. There's my unit I'm trying to get to. 1 decameter is 10 to the first meters. So again, maybe you want to do the math first. So it's 0.54 on the top and then 10 to the first on the bottom, and then divide that out. So you get 0.054 would be your final answer. Again, guys, I know this is a new concept, so take your time to practice this. There's lots of conversions here. There's metric on the top. I'll be honest, guys, the metric are probably where you're going to be more confused because we don't use the metric system here in America. Focus on being able to do these. If you can do these 4 at the bottom and feel pretty confident, you're on the right track, okay? There's extra practice in the practice binder, so make sure you do that. Don't move on without mastering this. Till next time, I'll see you later.